Okay, just getting the camera set up here. Now this question is telling us that cream is approximately 22% buttermilk fat. So we have cream, which is 22% buttermilk fat. And then we have our milk, which is 2% buttermilk fat. And they want to know how many gallons of cream must be added to milk that tests at 2% buttermilk fat. So how much cream we're going to add to this milk to come up with 20 gallons of a mixture, and we want to end up with 4% BMF, which is buttermilk fat. Alright, it's not too bad. You just have to watch the setup and you have to watch the decimals. So here we go. Basically, we can go back to our little diagram that I like to write out. This is going to represent milk. This is going to represent cream. And this is going to represent the mixture. Alright, so we're going to have milk, we're going to add cream, we're going to add the mixture. Now, we don't know how much milk we're going to use and we don't know how much cream we're going to use, so we're just going to call it X and Y. Now whenever we have two unknowns, what we're going to have to do is use what we call a system of equation, but we'll get to that. But just for our pictorial purposes, the milk is 2%, the cream or buttermilk fat, liquid BMF, the milk is 22% BMF. And then we're going to come up with a mixture of 4% buttermilk fat. Alright. So, when I look at this, got our 4%, X plus Y is going to equal 20 gallons. So, that's equation 1. Alright. And then 2 or 2%, 0.02, 2%. We have to learn how to transform the percentages into fractions. So 2% is 0.02, X and Y is 20.22 Y, and that's going to equal the quantity of 0.4 times 20, which is going to equal 0.8. Alright, so that's how we set it up. Now, let's take it to the system of equation, which is basically going to be a similar thing, but I had to give you a pictorial relationship. So we have X plus Y equals 20, milk at 2%, cream at 22% buttermilk fat equals 20 gallons, and then 0.02X because it's 2% buttermilk fat, and then Y is 0.22Y and 0.8. Okay. If you need to pause, hold off for a minute, you can do that and let it sink in. Let it run a couple more seconds and let it sink in. But that's why it's cool to have video. You can stop. If you get a little lost, you can back up if you want. So now, this is a system of equations, and what I can do is I can manipulate equation 1. This is equation 1, this is equation 2. I can manipulate the equations, because what I'm going to do is I'm going to separate this into 3 columns, and I'm going to add downward, and I'll show you what I mean. The reason why I want to do this is because I want to isolate X. So when I'm trying to solve the X and the Y in 2 different equations like this, what I can do is I can multiply the top by negative 0.22. Why did I pick negative 0.22? Because I want to isolate X, and it's a simple number. So what I'll do is I'll go to the Y variable and say this is the number I want to use, because when I multiply this, then I'm going to have negative 0.22X and negative 0.22Y, and then we have to multiply it by this as well, and it will be negative 4.4. So when I add downward like I said, I wanted to isolate the x to find x. I will know that negative 0.22y and positive 0.22y, they do what? They cancel out, so they give me 0y. When I add down here, I'm going to get negative 0.20x. Alright, you just, okay, I'm good with that. And then when I add downward, negative 4.4 and a positive 8 is going to give me negative 3.6. Now, when I divide both sides, or let's have our equation first, and then we can do things algebraically. So negative 0.2 x, equals negative 3.6. When I divide both sides by negative 0.2, my answer is going to be 18. 18 represented milk. So if our total mixture is 20 gallons, I'll put 20G, 2G, G representing gallons. This is how much milk we're going to use, and this is how much butterfat we're going to use to obtain that 20-gallon mixture with a 4% buttermilk fat percentage. Now, I'm a firm believer in testing, so nobody could tell you that you're wrong once you work this out. So what we could do is we can understand, back to our milk was X, cream was Y, and the total, okay, so this was 18 gallons at 2% buttermilk fat. This is 2 gallons at 22% buttermilk fat. Now, all you have to do is you take your gallons, and total, this is 20 gallons, sorry. Alright, so all we really need to do is multiply our quantities by our percentages, but we have to change them to decimal form. 0.2 is 2% in decimal form, and 0.22 is 22% in decimal form. So at this point, what I'm going to do, all I need to do is multiply. I will get 0.36. And let me just double check here with my calculator. 18 times 0.02, 0.36. Okay, and then we take our 2 gallons and multiply that by 0.22. 44.44. So these are the amounts of the buttermilk fat. Alright, if we take 18 gallons here and 2 gallons here, this is actually the higher percentage, and that's why we get a bigger number. But if we add 0.36 plus 0.44, we get 0.8. Alright, so 0.8. So is 0.8 4% of 20 gallons? Because these are the buttermilk fat percentages. When we looked at it, we looked at it, right? 0.36, 0.44. So 0.80, sorry. Alright. Well, I can tell you that we're close, because if I want to find our total, which is 20 gallons, if I want to find what our total is, alright, and percentage-wise, okay, if I take this decimal, which is here, I move it over 1, this is 10%. So 2 is 10% of, or 2 gallons is 10% of 20. Alright, so 5 gallons, we split that in half, we'd have 5%. I'm sorry, 5%. 1 gallon is 5%. Alright, So we need to be at 0.4%, and we're probably right there. I know we are. But another thing you could do is you can multiply 20 times 0.04, which is 4%, and I promise you, you get 0.80, which yields the total amount of buttermilk fat that we need to get that 4% mixture. So again, I know it's a little tough to grasp, but your setup is the same, keeping everything consistent and trying to do everything the right way. When we have two unknown variables, we have to use a system of equation. Alright, so that's that. Thanks for watching.